Sweet. We're up. We're ready. We're rolling. All right. For anybody on YouTube or everybody on the Zoom call, I'm Austin Lovelace, and we have Kevin Ten back with us finally. Or I guess it looks like he just dropped off. Look at that. He's right as soon as it clicked. Well, anyway, Kevin's been on vacation for a while, so good to have him back. But yeah, we've got Joshua here going to talk about data analytics on AWS. Yeah, I'll go ahead and hand it over to you and just do your thing, man.
Sounds good. And I'll stop video just to save some bandwidth. Hopefully you guys can see my screen.
Cool.
All right, let's get started. So hello, everyone. I'm Joshua Detective Walker. I recently changed roles within my corporate gig, but spent most of my cloud tenure in big data and sensitive data apps on AWS. I've been meaning to participate in this forum for a while, so thank you guys for having me. This session is meant to just go through all of the considerations when creating AWS native analytics applications and workloads. I myself am a cloud agnostic, professional. I also work in Azure and GCP and some VMware. We will do a nice brisk walkthrough from collection to storage to data to processing to visualization and so I'm hoping this serves as inspiration in a lot of areas as far as like what you can do and what you can enhance at your own workplace or for your own business. Maybe even in the future, if there's one specific topic I can come back and dive deep on, we can set that up. A lot of the materials pulled directly from working with like the AWS, like from my own experience from working with the AWS TAMs, which are like, the technical managers that you work with in enterprise. And then also from a lot of the like prep I've been doing for the data analytics specialty exam as well. So particularly a lot of this information can be directly applied to studying for that exam. And I'll let you know how it goes if we can stay connected after this. And I'll give you my email at the end in case we run out of time for QA or what have you. And so there's a lot to cover, so I'll get started there. So for starters, I wanted to kind of eliminate the stranger danger factor. So a little background on myself. As I stated, I'm a solution architect. I work for a global consultant firm, but I'm also co-founder of Black Orlando Tech, which is a tech nonprofit with a really big goal to get 10,000 net new minorities into tech by 2025. A lot of my sensitive data work experience comes from two types of orgs, which are, expanded extensively due to the negative effects of COVID, which is banking and life sciences. So obviously with all of the loans, just needing to do a lot more online banking, that industry exploded. And then same for life sciences, where I was working with a lot of teams that were actively fighting, the virus or sorry,
you cannot do two things at a time.
Sorry, someone asked a question. Oh, sorry about that. I'm also a newly published author, but we'll talk about that in a second. I've been in the Orlando tech scene, based in Orlando, Florida, my entire tech tenure. And I credit, the Orlando tech scene and scenes like this and events like this for, bringing me where I am today. I love doing these talks because it gives, lifeblood into the community as far as like everyone getting together to talk about very important tech topics in the cloud space. Also, and just to wrap up, I'm also a musician and formerly trained audio engineer, as well as an Army veteran that had the pleasure of serving. So with that, and I guess my last intro slide is, this is my book, Venti Fried Chicken, which really encapsulate my life mission and experience. It's the story of how I basically went from Army vet to at one point losing it all and being able to gain it back all through, through technology. I think technology is one of the most practical transformation fields for just overall economic empowerment. I know also looking to get in, I'm also looking to do a lot of stuff in a practical sense for education reform, because I think we're not training, the like the youth to go into jobs that that we'll actually need. As you guys probably know, we're in a pretty big tech deficit as far as like always needing, you know, these roles, especially in cloud. But with that, I'll jump off the soapbox. So the table stakes of analytics really are the following: storage, collection, processing, visualization, and security. Security is the last on the list, but definitely most important. Of course, nothing we do matters if it's not secure, especially when we're talking about sensitive data like PHI and PAI. And for those that aren't familiar, PHI is protected health information. Under the US law, it's really info about health status, provision of health care, or payment for health care that is created or collected by an entity. So really the information that you don't want anyone else to see but yourself, or you're releasing like, you know, someone on your side, like a hospital, to be able to see this data to help you out. And then PI is personal data, personal data, also known as personal information. And this is all around stuff that I can identify you. So if we said, you know, this is Joshua Tech Dev Walker in Orlando, you know, there's only that. So it's like what those puzzle pieces that help you identify a person is kind of what PII falls under. And then while also keeping, we need to basically keep every step secure in this kind of flow, as there's a lot of breakpoints. There's a lot of places where there could be data leakage and stuff to be compromised. So security always at top of mind for sure. And I think one of the biggest challenges we have is helping our clients and organizations move from kind of a monolithic mindset. A lot of times it's not that they don't want to change, they just don't have anyone to really like shepherd them, to give them like an apples to apples comparison on advantages that they have with basically going future forward in the cloud as far as like analytics and data. These monolithic approaches also give cloud kind of a bad rap, as they, you know, did not optimize to actually like take advantage of the cloud. As we all know, if you lift and shift, you most likely are going to pay more with only a few advantages. And the old way was expensive, had a ton of dependencies, and was very error prone, as you had little visibility, and it was very hard to scale as well. And if you did scale, you were exponentially scaling your cost as well. With the new wave, you have a robust, you know, decoupled architecture that you can leverage, which means if you have an issue with the service, it won't cascade into everything else, which is, you know, bad for all. As you're before in this kind of all EC2 setup, if you had, you know, your ETL process that's running on this one machine break, then it probably was a huge dependency breaking everything else in the chain. This new approach is also infinitely less expensive, as most of the services are managed services, meaning you don't have to worry about the compute scaling or patching in most cases. This also great about these managed services, they are basically right sized all the time. So I'm sure a lot of us have had a team that wants like what I call like the big one during deployment, but then, you know, they quickly cry when they see the double XL EC2 cost, you know, at the end of kind of that project, or even worse, a proof of concept. Also, it's not on the slide, but handling failures is another benefit of these microservices, especially important in the collection and ingestion phase, as losing large sets of data can be difficult to recover. And you know, if you're losing data, especially on the scale that I've been working with clients, then, you know, you're quickly going to not be the person that they're using as a vendor. So I would encourage everyone, let's definitely read about the dinosaurs in books, but let's not invite them back to kill innovation. So definitely looking to hopefully inspire some people to be advocates as well. With that, let's get into the first bus stop and kind of the data lifecycle collection. Hopefully someone caught my nerd dad jokes, as this is the collector from Marvel Comics. He's usually got a lot of his data from private data sources. So data collection is the process of gathering and measuring information on targeted variables and really an established system, which then enables one to answer relevant questions and evaluate outcomes. which then enables our data collection is really a research component in all study fields, including physical and social sciences, humanities, and business. So if this was the process of making a diamond, this is really spotting where you're going to go to collect the coal and then picking it up. I also think collection is an underrated skill. The person that knows where to get the data will never go hungry, whether that's knowing private data sources that you can pay a subscription, or doing something more manual like data scraping, where you're having to literally scrape and refine yourself. Some questions you want to ask are around what characteristics are needed for your collection system. What's the frequency, volume, and sources of data in question? How will you tackle the order, the format, compression, because data, it's not called big data for no reason, can have a lot of cost and definitely cost. So with that on collection, I just wanted to, before we dive into particular services, I think it's important to give a side-by-side of the ingestion services. I've purposely chosen to show only AWS managed services to give a nudge in the right direction, meaning not really just all of the services that don't require a ton of configuration, as far as like what I said before. As you can see, we have a ton of different options for different scenarios. As you can also see, all of these services are highly available, with being spread across 3 AZs of redundancy, which is nice. At least if you're doing the apples to apples, like the HA part is not as big of a concern, meaning your data is replicated in 3 distinct locations in case of disaster. As you can also see, what really separates the services at a high level is really the cost and data retention. And we'll talk a little bit more about how those things kind of differ and change. But I'll be talking a little bit more in depth about kinesis data streams, but the cost is a big factor. Whereas if you're looking at this, DynamoDB seems pretty awesome, but it's higher on the cost spectrum. But sometimes it's needed, if it's the right tool for the job. So now that you have a high level view of the possible ingestion points, kind of what's the real decision tree? It really starts like anything else, which is discovery, working backwards from your data project is trying to accomplish. So with working with like specific data applications, as far as like health records, or working with data science, like they have a different separation of concerns and different outcomes they're looking to get. With batch data such as app logs or media files, you're typically dealing with larger event hauls and ingesting those on like an hourly, daily, weekly basis. Whereas batch data usually is also bound by the data origin. If you're ingesting data that's stored in a specific S3 bucket, the collection process will kind of complete once you finish looking at that data for that specific bucket. The data is typically colder in nature and doesn't need to be processed on the spot when we're talking about batch. For streaming data, such as like click streams, like if you're talking about social media or IoT data created by hardware devices and sensors, like if we're talking like traffic lights or meters for electricity, these are usually ingested in real time. Streaming data is categorized by reading in large amounts of like smaller events. So if you're thinking about, how many triggers and how many bits of information are coming from a traffic light on any given day, like, could be thousands, sometimes hundreds, thousands, if it's like, talking New York City or something like that. Streaming data is categorized by reading in large amount, like if an IoT device is constantly emitting 15 like KB halos, and then you need to continuously write to your data stream. With this streaming data, you typically need to bound data by time, event amounts, and particularly segment to limit how much data you're processing in order to emit results in real time. As you can imagine, things can get choked up, with having a lot of I like the idea of AWS saying like kinesis fire hose, because I think a lot of times data, that's how it works. It's like water, streaming through a hose. So obviously if you had more data than the hose can handle, that's where you kind of get a choke point. And if we have hot data coming in at a high frequency and want to process that in real time, um, a streaming solution is typically the best option. Transactional data is, and to kind of round it out, I just want to talk about transactional data for a second. This data consists of records and data structures coming in from really transactional DBs. It needs to be stored quickly and be really easily accessible, because a lot of times, you're getting a lot of ad hoc queries from usually the data science team or whoever is kind of the analyst on that project. To ingest this type of data, you need an ingestion method that can capture and load continuously, changing updates to show kind of the diff between things. And we'll talk about kind of the order of data and things of that nature here shortly too. So some common ingestion problems, because I think, it's always great to talk in a perfect world, but things break. So I wanted to, kind of spotlight this. More data also equals you're really just more problems overall. Our first common problem is really duplicate data. Duplicate data puts an increased load on your data stores. And of course, it clogs up the system with unnecessary information overall. This duplication can affect the accuracy and reliability of reports as well as cause latency and, kind of a bunch of things that we don't want. As you can see, this can also harm the business because your data isn't accurate and you're paying for more data as well. So our second common problem is data coming out of order. If one record contains a reference to another record, it's important that it's referenced, processed first. Like, so the way data comes in, there's a lot of times there's a dependency on the order it's coming in. Your processing system might need to perform data lookups or relevant records. So this might cause the resource contention. It might cause latency, even performance degradation, because it's basically if we're thinking just like a running process, it's trying to tackle a bunch of stuff all at once if it has to kind of backtrack to account for the order. So an example of that, if the kinesis producer is sending 3 different messages, ABC to an ingestion point, to ingestion point, the messages arrive at the system in this order. However, these messages could be consumed in another order, and B record comes or C record comes before B, and this is not going to be good. So some of the common fixes for this are to prevent some of the problems that arise when you have duplicate data receiving out of order data. You need to pay attention to really 2 ingestion tool characteristics. One is delivery, AKA deduping. So, and the second is guaranteed ordering. So if your use case requires that you receive data in the order it came in, check whether the ingestion tool offers guaranteed ordering. Some services that have guaranteed ordering and delivery deduping includes DynamoDB, Amazon SQS, and then one isn't talked about a lot is Amazon MSK, which is Amazon's managed version of Kafka, which is used for basically event streaming. But those are 3 tools, DynamoDB, SQS, and Amazon MSK, that have have deduping kind of built in. As Kinesis is typically a valuable solution for ingestion on a lot of different types of workflows, I want to do a quick run through of the components. With Kinesis, you have the producer, kind of AKA the creator. With KPL put records, this is what brings things into the stream. If the records fail, they're added back to the queue automatically, which is nice. And if one record fails, it acts as an isolated incident. So you won't have a situation where your records are corrupting each other, which is also a great feature of everything. And then for Kinesis data streams, it's kind of like the highway. You replicate across, the different AZs. Not really suited for long-term storage, but kind of my rebuttal on that is that if it's the highway, you don't park on a highway. So it's really just for you to kind of get the data across. However, it can be retained up to a week. The default is 1 day, or 24 hours rather. and you could elongate that out to 1 week. But if things are architected correctly, in my opinion, you wouldn't want to kind of have that as a landing zone anyway. Kinesis consumer library is kind of the processor and record keep. It intakes the records from Kinesis data streams, and it keeps a track of what has come in automatically in DynamoDB, which is pretty awesome. And so that you have kind of this living and breathing document, if you will, that has all of the data records that came in. And then it's always right sized as well for the consumer library, where your hose, if you will, is expanding and contracting based on how much data is coming in. Because speaking of the consumer, let's talk kind of some consumer pro tips based on for the KCL. It creates DynamoDB tables like automatically on your behalf, like I said. So it's good to use unique app names for each app. I'm also a big proponent of like just the SRE, site reliability engineering function, and this will help a lot for monitoring. So if you're not meticulous with this when you're trying to monitor like your breakpoints from A to C, having this uniqueness will help with setting up like dashboards and things of that nature. So Kinesis data stream records are also skipped when using the client library. So this is usually due to unhandled exceptions. So the fail-safe, and this is a fail-safe to help us, but it hurts us in the meantime if you don't account for it, where obviously an infinite loop of any kind is bad. But so to avoid this, really, you're going to need to use the process records and build in your exceptions there, which should be a part of kind of the discovery of like when things are coming in, how can they break, which is why I brought up the SRE function. With that, so now that you have kind of the data where it should, like the data's in, where should it live long term? So we need to determine a few things with storage. How does the particular storage services operate? How will this data be accessed in the wild? Because another thing I've studied extensively is around user experience, and I think a lot of you can attest that usually when you build something, someone always uses it some weird way that you didn't think they were going to use it. What's some of the other things that you would want to consider is what's the schema, structure, format going to be for this data, and sometimes it's us being more good stewards to like us as the stewards of the environment, where a lot of times the data science team or the data team, or at least in my case, are the ones kind of handle like owning that piece. But and then you also want to know how you're going to intelligibly use data lifecycle policies and really eloquently move our data into like cheaper tiers, while also accounting for like regulatory compliance. So I talked about like life science and banking, and it varies here and there, but a lot of times there's usually a compliance contingency of having records around for a certain amount of years, but you don't want to pay for the hottest tier of data for, if you need to keep something for a decade. So, and a lot of times the data just needs to be there. It doesn't mean it has to be accessible right away. Lastly, figuring out how data will be cataloged and how you're going to handle really metadata. And if you're not familiar, metadata is just data about data. So, think like resource tagging, like this is data about data. So one big decision you might have to make is whether your data will live in kind of an operational data store or an analytical data store. Operations data stores, aka OLTP, are mainly like transactional data and are built for quick updates. These storage systems are designed for really like high volume, low latency, and are often regular repeatable workloads. Kind of some examples of OLTP or characteristics really is data store in row-based format, smaller compute sizes, low latency, high throughput, high concurrency. Concurrency on DB just really allows users the ability of like ability of a database to allow multiple users to affect multiple transactions. So you have, multiple people doing queries and writes and adding and dropping tables from in the same database and saying that concurrency can be handled in AWS. The high change velocity, this is also usually a good fit for caching as well, and also for mission critical HR, DR, and data protection. And then for the analytical or analytic data stores, rather, consist of two different types of data stores. Really, the OLAP and then decision support systems. OLAP systems provide kind of a more responsive framework for real-time feedback and ad hoc queries. Some characteristics there. And when we're talking here, we're talking more like your distributed data lakes, your data warehouses, usually for like long running query aggregations and projections, where kind of latency is really important because of just the massive scale. Because a lot of times if you're using like a Redshift, you have a very robust system that you're catering to, or ecosystem that you're catering to. Compared to the operational data stores, analytic data stores are usually stored in like columnar format. Data sets are large and usually use partitioning, just kind of breaking up the data in more pieces. Large compute size, which can be expensive, and I think we'll talk a little bit more about Redshift costs. Regularly performs like complex joins and aggregations. So going back to the ecosystem of like data scientists working in a database, a lot of times, one database doesn't have nearly all the information they need. So maybe they're joining from multiple so that they can get a full picture of the question they're trying to answer. And then I think that kind of covers, at a high level, and then kind of the services that fall in that category. For OLTP, you got RDS, Elasticsearch, Dynamo, Neptune, which I hope to use Neptune more in the future. I've been reading up a lot about it, but haven't had to do any kind of enterprise thing with it yet. And then S3 and Redshift, of course, on the OLAP side, as I talked about, enterprise data warehouses and distributed data lakes. And then oh yeah, so I just wanted to talk about principles to help choose your data store. So hot data is typically cached or stored in NoSQL databases, like where warm data leans towards kind of SQL data stores. Amazon S3 has a wide spectrum that spans kind of all of the different temperatures as far as data sets, whereas Glacier for S3 is kind of cold data, or archival is probably the better way of saying it, and usually kind of the last step on the ladder of stuff progressing into colder storage. Another detail needed in deciding whether your data is stored, or where your data is stored rather, is the structure of your data. One of the major decisions per workload you have to make is if you're going to use a data warehouse or a data lake. Data lakes give you a lot of flexibility and don't require pre-processing of the data before it's usable. It's also really great when you're working with like a data scientist, and I'll say them like so many times just because a lot of people I work with. It's also great for experimentation when working with them, as they can take the raw data and do their own computations, where if something already went through an ETL process, it's shaped based on certain criteria, and it'll be hard to reverse engineer or figure out why it got to that state. So a lot of the times with data lakes, we want this raw data so that I can basically turn this coal into the diamond I'm looking for, not something you handed to me. So these are, and I won't drain the slide here, but these are kind of the decision points. And I should have said this in the beginning, that I'll look to kind of export this and make sure you guys have these slides if helpful. So as I talked about earlier, you want to kind of gracefully move your data into colder and colder storage over time to save cost and eventually get rid of old data, even if it's years later due to regulatory compliance. one of the ways you can transition your objects stored in Amazon S3 is by using lifecycle management. A lifecycle configuration set is a set of rules that define the actions that Amazon really applies to a group of objects. So when you configure this lifecycle management for S3 objects or a group of objects, there are two types of actions. You got your transition and expiration actions. Your transition actions define when objects transition into another storage class. A good example would be you choose to transition objects to Amazon S3, like standard IA storage, 30 days after you created them, or archive objects to Glacier after 1 year. So just really that automated response to the data lifecycle versus you manually moving that to colder storage. And then this is something I think I'll be able to experiment with more here soon too, as I know S3 has kind of the this machine learning layer now too, where they kind of have the smart tiering where AWS is helping you determine on the fly where it's, based on how many times your data has been accessed. So definitely something to look into. And then expiration actions define when objects expire. So once an object expires, then Amazon is going to delete it for you. So of course, be careful with what you put in that category, but long as it's methodical and you get everything approved, shouldn't be too big of an issue. And I think a lot of times we have backups of a lot of data, and by the time it hits the deletion stage, it's probably super stale. So I know we're jumping all over the place as it's a big topic, but wanted to quickly talk about some points for DynamoDB optimization. In case you haven't used DynamoDB, it's a NoSQL managed database, which means it's key value and document based. A key value database, aka key value store, is a data storage paradigm designed for really storing, retrieving, managing associative like arrays and data structures, more commonly known today as like a dictionary or hash tables. Some of the enterprise uses for Dynamo include like using personalization, things like social media, profile management, real-time big data, IoT, certain types of mobile applications that are very semantic, digital communications. Really, when I think DynamoDB, I think about like very detailed semantic, like data points that you're using to craft like a very specific story versus like answering questions, if that makes any sense. But on top of the optimization, best practice is to really choose a partition key with like high cardinality, aka like a high number of distinct values. And use a good example would be like a user ID attribute, as the specificity helps cut down really the margin of error. And then also use secondary indexes. Really, a database index is really a data structure that improves the speed of like overall data retrieval from like a DB table. We have to consider how data will be retrieved by like the end user or end system, which we call like your access pattern. And if your primary key can't meet all your patterns, you can use kind of a spin-off index as like as your secondary index, and they're synonymous. And what this does is this really speeds up how you're putting, because you aren't putting all the weight of your primary index. And I know this is a crude example, but it's almost like it's not a read replica because it's it is definitely another index, but really just I'm kind of spreading the load. Also, something I realized I missed from DynamoDB that's not on the slide is around compression. For file size, DynamoDB currently limits the size of each item that you store in the table, and you can see the limits in like the DynamoDB documentation. But if your application needs to store more data in an item than Dynamo say you can do by default, you can try compressing one or more large attributes or breaking that item into smaller pieces. Think kind of like partitioning. And you can also store the item as an object in S3 and store the Amazon object identifier in DynamoDB in a DynamoDB item, meaning you're saying, we have infinite storage capabilities for S3. So I just want you to use this ID exists in this database, but it's actually sitting in S3. So hopefully that makes sense. Like it's like a pointer versus you holding that data in the actual database. And then for compressing the data, compressing large attribute values can allow them to fit within item limits and reduce your overall storage costs. Compression algorithms such as like gzip produce binary outputs that you can then store in like a binary attribute. So you can basically basically force compression based on criteria, which is nice. Excuse me, grab some water. And then I also wanted to point out optimization for Redshift as a widely used resources, especially within the enterprise. Like it's a big deal and widely used. Redshift is a MPP system, which stands for massively parallel processing. MPP is the coordinating processing of a program like by multiple processors that work on different parts of the program, with each processor using its own like operating system and memory. And then when we're talking about choosing the right distro style, when you load data into a table, Redshift disperses the table's rows to different nodes, and it slices and dices according to the distro style. So you choose this when you create the table, and then the distro strategy that you choose for databases has kind of important implications for query performance, your storage requirements, data loading, and maintenance. So by choosing the best distro style for each table, you can balance your distro and significantly improve your performance. So it's a good consideration to think of when you're thinking Redshift. And the right sort key is also an important topic. When you create a table, you can define one or more of its columns as sort key. When data is initially loaded into the empty table, the rows are stored on disk in kind of a sorted order. Information about the sort key is passed to the query like planner, and the planner uses the information to construct plans like to exploit kind of where the data is sorted, and you can really specify either compound or interleaved sort keys. So I just wanted to talk about interleaved keys and compound keys, just to kind of talk about the difference. An interleaved sort key gives kind of an equal weight to each column in the sort key. So querying predicates can use any subset of the columns that make up the sort key in any order. The performance upgrade you gain by implementing an interleaved sort key should be weighted against kind of the boosted load and the vacuum times. Don't use any interleaved sort key on columns with kind of monophonic attributes such as like identity columns, dates, timestamps, things that kind of need to be stuck in the sand, like that shouldn't change. For a compound sort key is more efficient when you're querying predicates using a prefix, which is a subset of the sort key column in order. So compound sort keys might speed up the joins, where we're talking about like group by or order by, which are very common commands because you're trying to group data or order in a certain fashion. And then also window functions like partition by and order by. A good example is a merge join, which is often faster than a hash join. It's feasible when the data is distributed and kind of pre-sorted on the joining columns. Merge join is used when projections of the join tables are sorted on the join columns. Merge joins are faster and use kind of less memory than hash joins. Hash is really used when projections of the join tables are not already sorted on the join columns. And I know we went down kind of a join rabbit hole, so hopefully it's still helpful. The performance benefits of really compound sorting decrease when queries depend only on second sort columns without referencing the primary column. So kind of that separation of concerns and separation of resources. compound is default sort is the compound is the default sort type. So with that, I'll move on from Redshift because I still have a decent amount of ground to cover. We can't talk about data without talking really about native backups for common storage resources for Redshift. Snapshots are point in time backups of a cluster, similar to any snapshot that you're doing for any EC2 really. And there are two types of snapshots, automated and manual, as I think most are used to. Amazon Redshift does store the snapshots internally in S3 via encrypted SSL connection, so good handle of security there. And Amazon Redshift automatically takes the incremental snapshots that track changes to the cluster as well, since kind of that previous automated snapshot, so that diff between the two. And then automated snapshots retain all the data required to restore a cluster from a snapshot as well. You can also create a snapshot schedule, which is probably the easiest thing to do, or it might take some thought up front, but then be the biggest benefit. Or you can take a manual snapshot anytime you want, if you have some maintenance to perform or something like that. For Dynamo, Amazon Dynamo allows you to perform backups on demand as well. It also allows you to create full backups of your tables for long-term retention and archive for compliance, which is good based on the use cases I talked about earlier. You can also backup and restore actions execute with zero impact on table performance or availability, which is pretty sweet. So you can, take these kind of backups without any degradation at all to what you're doing. So operation as normal while you're doing backups. It uses a unique and distributed technology that really allows you to complete backups in seconds, regardless of table size, which is, I'm glad I'm not the dev that had to engineer that. And you can create backups that are consistent with seconds across thousands of partitions as well, without worrying about schedules or long running backup processes. So very robust solution with DynamoDB, very well thought out by AWS. All backups are cataloged, easily discoverable, and retained until really explicitly deleted as well. And then last but not least, because it's such a commonality, maybe even more common than Dynamo and Redshift, I wanted to just talk about RDS. RDS creates automatic backups for your database instance during the backup window of your database instance, which is managed by AWS. Amazon RDS saves the automated backups for your database instance according to the backup retention period that you can specify once during creation, and you can change as well. If necessary, you can recover your database to any point in time during the backup retention period as well. And you can also, last but not least, you can also back up your database instance manually, of course, by manually creating a database snapshot, whenever you need. And a lot of times those are used for, read replicas and things of that nature. So as I mentioned earlier, cataloging and metadata is important. Glue is one of really the most practical and robust managed tools to achieve this. Glue data catalog is a persistent metadata store. So storing the data of your data. It's a managed service that lets you store, annotate, and share metadata in the cloud in the same way you would in like Apache Hive Metastore. Each AWS account has one AWS Glue data catalog per region, so that's good to know for planning. It proves a uniform repository where disparate systems can store and find metadata to keep track of data in transit, and data silos, and use that metadata to query and transform this data. So how we put data in our store is what I just wanted to briefly go through. Is one, our crawler runs any custom, runs a classifier that you choose to infer the format and schema of your data, like the Parquet format, and then the crawler connects it to the data store. The inferred schema is created for your data, and then the crawler writes metadata to the AWS Glue data catalog. Glue is really its own gigantic topic, just like I think pretty much anything I've talked about or any service, you can go very deep on. I also wanted to say you can also host Hive Metastores on RDS as well. Hive is a popular data warehouse tool made by Apache. And I think a lot of times I see folks not know that they can, run that on RDS. So I wanted to mention it. The processing phase of the data analytics pipeline helps you choose kind of the right ETL tool based on workload requirements, performance, cost, orchestration needs. Really, the goal of the processing system is to transform data and make it more consumable by, the analytics and visualization tools. This module will kind of cover the concepts about processing. We need to determine, kind of the appropriate data processing solution requirements, also design a solution for transforming and preparing the data for the proper analysis, and last but not least, to automate and operationalize a data processing solution. So, it's not a one and done by any means, but you obviously you don't want to have like a bunch of manual steps when you need to process data frequently. So, and that's where ETL comes in, and ETL helps transform, flatten, and enrich your data from source to target. Really, the big goal is to really handle up to terabytes and sometimes petabytes of data. Really simplify the querying different data sets. So we talked about joins and being able to really have all your data in one place, be able to leverage it all in one place. Combining existing legacy data with modern data sets in one place. Which is kind of, I think, one of the advantages that if it's like a legacy application, I know we like to pick on those, but there's usually a lot of great data that if you pair it with like kind of your newer solutions, you kind of get a holistic picture of the organization and can probably drive a lot of innovation for the business. And then last but not least, preparing data for machine learning, which is kind of the final frontier. I think a lot of times, machine learning gets thrown out there a lot because it's kind of a sexy term, but it takes a lot of effort and it takes a lot of maturity for you to even get to a point where you can use ML correctly. However, ETL is great, but there's also some painful times, data volumes may grow or almost are sure to grow if you're working in enterprise. Additional data sources may be added. A large proportion of ETL is hand coded a lot of times. Data formats might change. Just to name a few, kind of pain points there. So fortunately, Glue helps take a lot of this headache away. AWS Glue natively supports a ton of data stores by using the JDBC protocol, which is an application programming interface for the programming language Java, which really defines how a client may access a database, which includes Redshift, RDS with all the 6 database engines that fall under RDS, and even non-AWS database engines as well, which is very practical, like Microsoft SQL Server, just plain old MySQL, Oracle, Postgres. AWS Glue can also generate ETL code in Scala or Python to just extract data from the source and transform your data. And of course, that depends on what team you're on, or like, what your engineering culture is. You can also provide your own script in the AWS Glue console or API. And once the data is transformed to match the target schema, the data is loaded into the target data store. And the AWS Glue data catalog contains kind of the table definitions, the metadata that is required to define the ETL jobs, and really leverages the metadata when you define a job kind of to transform your data. And I just want to talk about kind of some of the triggers that are out there. You could schedule it like a time-based trigger, like a cron job. You could do job events like conditional cron jobs, basically. You could do on demand, like just triggering a file whenever you need it. You can also, of course, hook this into other event streams or other event services, rather, like CloudWatch events, Lambda, if you're using like Lambda for like your kind of like your smart glue, or it's serverless application that has certain actions that you want to trigger off of, or you can AWS step functions as well. You can use with the Glue workflow. So the way they architected Glue, or how AWS architected Glue, has a lot of options as far as how you can use it, and plays well with pretty much all the data tools. To ensure that your ETL requirements are met, you really want to assess additional design considerations such as scalability, reliability, and really the cost of ETL in general. This chart compares AWS Glue, EMR, Lambda, Kinesis, and kind of show the different characteristics here. Glue is robust, but it's also cheap in comparison, and you're metered down to the second. So that's very helpful when it comes to trying to save as much cost as possible. And if you have used EMR, then you know how expensive it can get, especially if you're not like doing a lot of careful planning with it. A Lambda, of course, could wind up being way more cheaper, but you also have a lot more initial setup, because there's very few times there's going to be like a Lambda function or that you get straight from the marketplace that's specific to what you want to do. You're probably gonna have to do some type of re-architecting, if not building from scratch. And then all in all, you have to make the best decision for your business, but this gives kind of a good decision tree. And once again, hopefully I can share this, guys, with you as soon as possible, working with the organizers, so that you can have this reference. And although I picked on EMR, in some cases, it's still a very valuable solution. Depending on your workload, there are several ways you can take, to optimize EMR to still work for you. And there's a list of EMR considerations that you'll need to understand as you kind of stand up these resources. Like, you need to worry about the instance right sizing, which I think is one of the biggest killer. Is like, you make this gigantic fleet, and then when you start doing kind of some analysis on through monitoring, you see that you're only like using like 10% of your cluster, or maybe less sometimes, and that's that could be discouraging, and of course waste a lot of money. Amazon S3 versus like local HDFS is a consideration. Transient versus like a persistent cluster. Using spot instances, which you have to architect in a way where like if you lose your spot price and that compute moves somewhere else, you're not breaking a process and like killing a bunch of work. So making it so that you're getting quick outputs from whatever you process, and not like losing any data if your spot falls from under you. And then really elastic cluster versus static cluster. So really building scale into it versus I know exactly what headroom I need, and I'm just going to run static, and then hopefully at some point of maturity be able to do reserved instances to be able to bring that cost down. And I wanted to dive into each of these kind of design considerations to better understand some of the key characteristics and use cases. So for right sizing, you're launching several small clusters, and running benchmark tests will really allow you to choose the most relevant instance type for your workload. So I think a lot of times I'll say the acronym POC, proof of concept, like before you dive into something so robust and potentially expensive like EMR, definitely try and do some benchmark testing, see if you can do a smaller workload and just extrapolate on what that would look like at an enterprise level versus just turning on this gigantic machine all at once for processing. And then EMR supports standard high CPU, high memory cluster compute, high IO and storage instance types. So you also need to make your EMR like kind of workload work for you based on your particulars. Far as I won't get too much into the S3 versus local HDFS, because on being more on the DevOps side, I can't speak to like the super big trade-offs versus HDFS versus S3. I know I've worked on both, and they both have certain advantages. For transient versus persistent clusters, you can lower the kind of the operational cost of your solution by running the Amazon EMR cluster only when it's needed. So remember that Amazon EMR, which I think gets skipped over a lot of times, are made up of EC2s, and they're billed by the second now. So if you can architect if you know your workforce is only working 8 to 12 hours, then having these automatic shut off that you can set with a Lambda or a cron job to shut everything off. I think so expensive, like a lot of times things become expensive when you're just letting it run without using it. I think the hardest thing is when you have like a 24/7 workforce, which is the case a lot of times where you have kind of a follow the sun model. And then for Amazon CloudWatch events, they can really help defend your EMR's life. Like you can use events and metrics to track the activity and health of your overall EMR cluster. You can view like the events and metrics in the EMR console for a single cluster and really all your clusters and an entire region. So you can also use these events to like really programmatically respond to changes, like usually negative changes. You could also route that like the EMR step failures to Lambda for kind of automated retry logic, which is something I see a lot of great like or mature organizations for cloud do, which would allow you to programmatically kind of retry your jobs without any manual intervention, which brings you more into kind of the SRE like real operations where I just want my system to auto heal itself. So, and then we can't like logging and auditing is crucial, especially when we're talking about sensitive data workloads. You can enable traceability in the API and at the EMR cluster level as well. You should be able to view all your logs in CloudTrail. You can also review logs containing information on data written to the EMR master node. So like, you can keep track of what's happening to your brain, if you will, because that's the guy that's kind of making sure everyone does what they need to do as far as the other nodes. In Amazon EMR, you can view logs in, you could do like the archive logs in Amazon S3, or you can optionally view logs in your own debugging tool as well. So, and I've seen that a lot too, where you got to pump logs somewhere else. So because you have like a better view or a more practical way of debugging, outside of the AWS native solutions. And then onto Dataviz. So with Dataviz, you have a few distinct concerns. We need to determine the operational characteristics on really the analysis and visualization solution. So we need to select the appropriate data analysis solution for a given scenario. We need to select the appropriate data visualization solution for, or choosing the right tool for analytical problems. So like basically this, after all of that work, we need to be able to look at this thing and make determinations. In the interest of time, I won't talk about, I'll only talk about like two AWS native tools in Dataviz category, which would be QuickSight and Kibana. Also wanted to asterisk, a lot of times industry popular tools like Tableau and Power BI are used for this layer as well. But of course, with this being the AWS form, I think there's a lot of like native is great. And I think a lot of times because of certain things, we rush to third-party tools, but native has some great capabilities as well. For Amazon QuickSight is purposely built business analytics and visualization like service, and it makes it easy for really all employees within the organization to really build dashboards, perform analysis, get business insights overall. And it's good because they can basically get these insights about the data anytime, pretty much on any device. So it really creates this community of practice and accessibility as far as everyone using the same thing, which is also another SRE principle. Data sources and prep. Data sources and data preparation are a big topic. You can use a variety of sources for data analysis, including files, AWS services, and on-premise databases. Whereas Spice is super fast parallel in-memory calculation engine. And I know that's a mouthful, but really just handling your parallel processing. For visuals, also known as data visualization, visual is a graphical representation of data set using kind of a type of diagram. So your bar charts, your donut graphs, like things of that nature. And then for ML insights is very interesting. It basically there's an ML component built in the QuickSight where it could potentially give you useful visual based on evaluation of your data. So saying like, hey, I looked at your data. I think if you displayed it this way, it would probably be the best, which is I like a lot of the ML services that are kind of coming to flourishing in each service as they mature. And I think this one is really cool. And for sheets, a sheet is a set of visuals that are viewed together like in a single page. So almost think like a report. Um, and I won't drain it, but if you're looking to stay like 100% native QuickSight, it is definitely a slept on tool in my opinion, and has a lot of great features. And I think maybe it just sometimes needs a better PR team in the data space. For Kibana, I don't know why I'm going to say this, but as a young dev, I always wanted to work for Elastic, and one of the main reasons was they created Kibana. Kibana is an open source Dataviz and exploration tool used for login time series and analytics. Also used for app monitoring, operational intelligence. It's pretty intense. It offers powerful and easy to use features such as like histograms, line graphs, pie charts, heat maps. So I think Kibana is really cool because it's one of those things where like I come from somewhat of a Python background and some of the data science stuff, and that's how I got in the cloud. And it handles a lot of like the hardcore visualization that you'll do with kind of like pandas and other frameworks that data scientists use. You have a lot of like interactive charts. Kibana offers really a lot of intuitive charting and reporting that you use navigate through like large amounts of log data. So as you know, like logs can be like a needle in the haystack and what makes logs useful is if you can really like chop down to what you need at a point in time really quickly, and Kibana really helps with that. They have mapping support as well. Kibana comes with powerful like really geospatial capabilities, so you can like layer in geographical information on top of your data. So obviously if you're doing that type of work where you're like really COVID-19 is a good example of like a data scientist needed to layer everything on top of each other to tell a story. They have a lot of great mapping support there. A lot of great pre-built aggregations and filters, just really being able to slice and dice, look at trends, like I said, histograms, which is a very sophisticated type of way of looking at the data, easy dashboards, and then last but not least, I would just say the managed Elastic ecosystem is really a huge topic on its own. So I encourage you to explore the other phenomenal tools like Elasticsearch, which usually, Elasticsearch and Kibana are paired together. And then you have some other, big tools that they use within the Elastic stack. And AWS, to my knowledge, has pretty much all of the major managed services for Elastic now, which is really great. It takes a lot of headache out of kind of the manual configuration there used to be like not even that long ago, in my opinion, a few years ago. And then for security, now into our last but not least section. Like I said before, nothing matters if it's not secure. Also, security is all of our responsibility, not just one department's responsibility. So let's jump into a few ways we can help, kind of smash vulnerabilities to kind of play off the Hulk and reduce your kind of overall attack surface through kind of these checks and balances within your resources. And so each specific analytics service has its own security kind of configuration features. Obviously, that would take like a few of these sessions to cover all of those. So due to limited time, I'm going to talk about kind of the security features that spread the farthest and more broad in nature. So with that, we'll get into this last section. I think we're all familiar with IAM, but want to briefly talk about it in the data context. When a user or an application makes a request to kind of the AWS services, they need to prove their identity to the system. So example, if you want to create an object inside of an Amazon bucket or an S3 bucket, you're making a request that really invokes like object creation privileges for the system to allow you to create, an Amazon S3 bucket or take something out of it or do a put command. IAM allows you to authenticate yourself through your users, groups, and roles. So now I want to really zero on I think we're all familiar with IAM. It's IAM is a really big building block. You really can't do anything without learning it first. But I wanted to talk about, IAM identity versus resource-based permissions. Identity and resource-based policies are nearly identical in appearance and function, but kind of have some slight syntax differences. The difference between the two types of permissions is where they're applied. Identity-based resources are attached to an IAM entity and really indicate that the user or group is for what is permitted to do, where resource-based permissions are attached to a resource and indicate what a specified user or group of users is permitted to do. So hopefully that helps. And I think it's a small distinction, not a cybersecurity expert, but hopefully someone's nodding out there. Hopefully that helps. Now let's briefly talk about network. A key security consideration is the network isolation of your resources. To properly isolate your resources, you'll need to configure, of course, your VPC. While not all services use kind of a customer configured VPC, most services that involve the use of EC2 instances do. So for example, EMR clusters use their EC2 instances as the master core, and task nodes are all EC2 based. So you're using, you want to basically isolate these resources within a VPC for obvious reasons. So you can segment, kind of these precious resources, have them in, a private subnet, what have you. I actually lied a bit, as I don't want to touch on two security services, but I wanted to talk about two security services that really I don't hear people talk about a lot. As IAM and VPCs are not the only security controls that you can really take advantage of. This is Apache Ranger is a role-based access control framework. It enables, monitors, and manages really comprehensive data security across the Hadoop platform. And kind of stuff you get with Ranger is the centralized security administration and auditing. You get fine-grained authorization across different components, including Hive, Storm, Solar, Kafka, Yarn, sync, and then you get sync policies and user by. You get to let me start over. Syncs. You get the sync policies and user by using agents and plugins that run within the same process as the Hadoop component. So having those things aggregated, and supports row level authentication and auditing capabilities with embedded searches as well. And then just quickly for Redshift stored procedures, you get fine-grained access control. You can create procedures to perform functions without giving a user access to underlying tables, which is nice, because I think a lot of times what people are afraid of is having data leak from a table, someone dropping a table by accident. So an example, only the owner or super user can truncate a table or drop a table, and a user needs write permissions to insert data into a table. So you can basically make it very fine grained on what they can do, really going super least privileged access, but on the data front of not harming your data warehouse, especially when you're talking about maybe users that are learning or new engineers, things of that nature. We all make mistakes. So just really protecting people from themselves and protecting the business. And then we're starting to wind down here, but you can also talk data or security, well, you can't talk about data or security really without encryption or tokenization. Data encryption and tokenization help protect sensitive data against really risk such as infiltration, unauthorized access. When considering really encryption methods and alternatives, the things you got to ask are like, do you need to use like a hardware security module like HSM to manage the top level keys? Do you need encryption at rest and in transit? That's usually a yes. Do you need an alternative encryption to secure highly sensitive subsets of data for like compliance? And then do you need to manage secrets, which is usually a yes as well, whether the question will be if you need to manage it or if you want to manage it in AWS or not. Some of the methods we have, and I won't like drain all the methods, but some common methods, you got SSC S3, which is like Amazon S3 manages the data and master encryption keys. You got SSC KMS, which is AWS manages the data key, but you manage the customer master key. So you're putting some onus on AWS, but you own like the God key, if you will. Just a few things about kind of cloud HSM. You should really only consider using AWS Cloud HSM if you require keys stored in a dedicated third-party like validated hardware security module under like exclusive control. Think like the government or some really sensitive thing where it's this needs to be under lock and key. FIPS compliance, which is usually in like the government sector as well. Integration with applications using like very specific things like Java, GCE, and interfaces, other interfaces like the CNG interface. And then also if you need high performance in VPC, like if you need like bulk crypto or cryptography rather, then HSM is a good help there. But last but not least, I just wanted to touch on tokenization. Tokenization is an alternative to using encryption. Tokenization helps protect certain parts of data that has high sensitive or specific regulatory requirements, such as like PCI. And I have gotten the pleasure of working on like GXP, which is a certain compliance protocol that acts as a variable, but it's good variable practice is why it's called GXP. And basically they have to be able to look at, if something happened, maybe in like the pharma world, they need to be able to track all the way back to the infrastructure level of where things went wrong. So tokenization might be a thing where you want this because you have this very specific data points that you want to kind of anonymize and keep safe unless needing to be accessed by specific people or specific systems. So it's just the next level there. And then for managing secrets, we have two AWS native tools I wanted to highlight, good old secrets manager and also the parameter store. You may need to use secrets within applications to connect to databases, APIs, and other resources. And these are two valuable options. Just because of time, I would definitely like look into the trade-offs on when to use what, because I'm not, like I said, I even though a lot of my my worry and concern and planning is around cybersecurity, I'm not a cybersecurity expert. So I would just say these are the two main tools I see in the wild and would definitely research. You can even automate this using, you can use like these tools with like frameworks like Terraform to automate things to like rotation policies so that your keys don't get stale and you can kind of enforce people to do the right thing. For my last technical slide, I just wanted to talk about config as you can use it to kind of enforce compliance to ensure that newly created, AWS resources and anything that happens within your ecosystem follows like best practices. I've been fortunate to work with a lot of great compliance teams, and config is one of those, kind of benchmark services that can help keep everyone in regulatory compliance by default. AWS config reports the configuration state of your AWS resources and allows you to really define custom rules to track desirable or undesirable like changes. And then you can even, work on like auto remediating some certain things. For example, you can use like config rules to monitor the settings of S3 bucket. Like if you don't want, people to do certain things like public buckets, then config can help you there. And then using AWS config to monitor state and Lambda to correct incorrect states of configuration will also allow you to enforce compliance in an automated fashion. Like I said, just really making it so unless someone explicitly opens up a request and can justify why they need to overwrite that, this is a blanket no across the organization. And I think that that's super helpful. And this is my last slide, and I apologize because I'm not sure if I'll have time for QA, but I will say, and maybe I can do this on the my email is josh@ventifriedchicken.com. Feel free to email me with any questions because I think I'll have to drop after this slide, but it's been really great. Hopefully you guys got a lot out of this. Obviously covered a lot of ground here. But yeah, that's it for the content for today. Great. Awesome. I know so many times I ran out, like I was like, I need to grab some water, so many words. Well, I'm glad you got a lot out of it. Thank you for having me for sure. Sounds good. Great. I look forward to it. I'll coordinate with you offline then. Yeah, if you guys have any questions offline, like I said, josh@ventifriedchicken.com. Always looking to network and talk with other practitioners in cloud. So even though I have to, abruptly leave, I'm definitely accessible, and thank you guys for having me.
Hey Josh, can you drop your email in the chat so we don't make typos?
Yes. 1 second.
Yeah. Thanks a lot for the presentation though. It's really cool, really helpful.
No problem. Thank you guys.
Yeah.
All right, everyone, have a good night.